Hey guys, welcome to Flight Plan. It is the SAE Aero Design podcast, back here for another season. I am a new voice on this. Well, actually, you probably heard me on the intros and the outros pre-recorded last year. I'm Michael Sorg, video professional podcaster here in the Pittsburgh area. And you might have seen me at competitions, filming things, working on the videos. Maybe I talked to a few of you guys, the students, the volunteers out there. This year, I'm going to be helping to guide these podcasts a little bit more with our friends here at SAE and Aero Design and everything. And we're kicking off. We're talking about a lot of the new rules, the advanced class, and everything today for Flight Plan. Today we have a crew with us, some experts on what's going on here. Let me go down the line. First of all, Sam Burrill. He's the University Program Manager at SAE in the CDS department. How you doing, Sam?
Good. Hey, welcome, guys. Thanks for listening in.
Excited for the new season?
I am. It's always exciting. I do like the SAE Aero Design competition. It's a great bunch of people. I like who I work with, and we're doing some good things this year.
We also have with us Sarah Guffey, Universal Programs Coordinator with SAE, somebody that maybe you've interfaced with out there as well, preparing for the season as well. How you doing, Sarah?
Hey guys, yeah, you've probably seen me at registration or talked to me through collegiate competitions. I'm the one that puts out all the information on saeaerodesign.com on the news feed, so you've definitely either talked to me or read something I've posted. So
awesome.
Sarah's probably the one person that most of the teams come in contact with between now and the end of the competition.
And we have on the line with us from Lockheed Martin, our friends from the SAE Aero Design. First of all, Lonnie Dong is with us. He's a Raptor Airborne Software Manager. That sounds really fun.
That sounds all right.
Sounds all right. Thanks for joining us. And of course, Tom Blakeney. He's an engineering guru today with us as well. How you doing?
Doing good.
All right. And you guys collectively, over 10 years plus on the community with SAE Aero Design. I know we've talked with you guys a little bit on some of the videos we did for last season in Aero Design, but give us a real quick background on what you guys, your experience here.
Go ahead, Lonnie. You go first, and I'll follow up.
Well, I've been part of the Aero Design since 1998 as a student competitor, and went through the program for 4 years. Graduated, and then was hired from Lockheed Martin to work on their Raptor program. And then after that, became involved with the rules committee and helped out with the scoring, helped out with some of the rules changes, and adding on the third class to the competition. And then I guess I've been involved ever since. And this year, we're kind of excited about adding that new class.
I got my start with SAE in 2006 as a volunteer pilot. I'm an RC guy, and our club hosts one of the events, and I've for 2 or 3 years I flew a volunteer, and then I was helping the club organize for the event. And the previous director of Aero Design, when it's held in Fort Worth, left Lockheed Martin for another opportunity, and I agreed to take over as event director for all the events that are held here in Fort Worth. So I've been doing that since 2014. I've been on the rules committee a little longer than that, and I've got the next SAE event coming up. The next Aero Design event is going to be here in Fort Worth, Texas on March 8, 9, and 10, 2019.
That's awesome. That'll be my first time in Fort Worth with you guys, so looking forward to it personally here. So before we get into the advanced class, I think a little bit of background. If there's anybody that's the uninitiated to how Aero Design works, there's actually 3 classes that are dealt with. Can we just do a real quick brief summary of what are the 3 classes that you will see in an Aero Design competition, guys?
Regular class is kind of viewed as the entry-level class for Aero Design, and it's the class that most student teams typically attempt as their first participation. And of course, there's also teams that have done it every year for many years. Regular class is an electric-powered aircraft. We have a power limiting system that limits the teams to 1,000 watts. They get 1,000 watts of power to use any way they see fit, and that's part of the mystique of the event, getting that right. And then the aircraft they cannot have any composite construction. They're limited to a 12-foot wingspan. They have to be built out of balsa or metal or spruce or foam, but no carbon fiber, no composites. We're trying to make it an easy to access event. And we've got 2 fun requirements. We kind of did a regular class a couple of years ago. We redid it as a passengers and luggage event. the teams have to, with that 1,000 watts of power and a 12-foot wingspan, they have to design an airplane that will carry as many tennis ball passengers as possible. And in addition to, for every tennis ball they have to carry between half and 3/4 of a pound of luggage. And that makes for a very interesting design problem, because you've got to have volume for the tennis balls, but you've got to be able to carry some weight in certain areas as well. And some teams have successfully gotten around the pattern. You had to fly once around the pattern to get a successful flight, successful takeoff, 1 lap, successful landing. And with around 60, I think 60 is a pretty high number. There might have been 1 or 2 slightly above 60, but I believe 60 tennis balls and 30 pounds of weight have been carried by these airplanes, limited to 1,000 watts of power. And that pretty much sums up regular class.
One of the things, how we came up with the regular class was to make sure that, we talked about adding the cost structure. How do we get cost structure to the competition? Because some teams may have a lot of money, some teams may not have a lot of money. How do we introduce cost? So we always focus on cost of the manufacturing, but never cost of operation. So if you look at the scoring equation for the regular class, it deals with the cost component of operation. This year, pay attention to the new rule. There is some cost implication to the scoring equation as well. So just pay attention to that. As far as the microclass is concerned, this is something that we developed back in 2009, I believe.
2005, I joined it. That was the first year we tried it. We attempted the microclass, yeah.
And it was mostly more of the concept between the microclass was about conflicting requirements. The 2 conflicting requirements originally was, carry as much weight as you can, or make it the lightest plane possible with the payload fraction. Has evolved over time to use different materials, but the same constraint is still there. Same concept is still there as building a small airplane, but this time we're carrying PVC pipes, and how again dealing with kind of volumetric items. We're limited to that's just special battery power associated with it. Is all electric.
Micro was the first electric class, and years later we swapped it regular to electric, and this is the first year for advanced to go electric as well. So we're now 100% electric on all events. And Lonnie was talking about the payload, which is interesting because we picked a low-density industrial construction material, PVC pipe, for the teams to carry, and it gives them some unique design challenges to be able to efficiently carry hunks of pipe on a very small airplane. And all their payload and their airplane has to pack into a certain size, not very large cardboard box.
And that's important to note that this is, out of those 3 classes, this is the one class that is a hand-tossed piece for the microclass.
That's right. The other 2 airplanes have to take off and land on a runway, regular and advanced, but microclass is hand launched, hand tossed, and does a belly landing at the end of its lap.
Excellent. And of course, advanced in the past, from what I observed last year, advanced was you had to deliver a payload into a target. And this year, it's going to be a whole different story. Can you tell us a little bit about what's new for advanced?
The technology in UAVs and small unmanned aerial systems and drones, if you want to call them drones, has been advancing so quickly that we felt a real need for aero design to keep up. And so what we did this year is we came up with a really fun idea, and Lonnie kind of came up with the outline. We're calling this basically a colonization mission. And the advanced class aircraft will still be carrying some weight and dropping some stuff, but the most unique thing they'll be dropping this year is a small autonomous glider that must weigh 9 ounces or less. It's going to get released from the advanced class aircraft, and it's going to autonomously steer via whatever software and programming the students come up with to a target on the ground. And they don't get any points. They don't get any passengers to the planet unless they get land. They don't get any credit for any passengers unless they land them in the target zone. And we think that's going to be a very exciting event. So each big advanced class airplane will be carrying a small glider, and it's going to be on its own to do its own thing, much like a Mars rover once it lands on the surface. So it's going to get let go in the atmosphere and have to get down safely. And then to be able to supply these colonists, we also require the teams to deliver supplies and habitats. And the supply they have to deliver is a 500 milliliter or 1,000 milliliter standard water bottle, full, unopened, and they can't break it when they deliver it. They'll have a drag streamer, and they can do other things as well to slow it down. And that has to be dropped on the target via crew coordination of the advanced class aircraft, like it has been in years past. And then one other type of payload is the habitat, which is we're using a fairly suitable toy. It's a Nerf Aero Howler Vortex toy football with the fins on it. And we thought those would make great, lightweight, safe, aerodynamic habitat deliveries. And so the advanced class airplanes will be dropping an autonomous steerable glider. They'll be dropping water bottles representing supplies, and they'll be dropping Nerf Aero Howler footballs to represent habitats. And Lonnie, why don't you kind of tell them about the scoring on that to kind of show how we blended it all together to make teams work hard to figure out the best strategy.
So the scoring is is an interesting combination. One of the things we talked about from the scoring perspective is, me start from beginning. I was watching the movie Mars with Matt Damon, and he survived as a lonely Martian out there, and they measure how many days he can survive by number of souls, which is number of days he can survive on what he had. So we decided from the scoring equation, why don't we score it on number of days the colonists can survive? That was the premise of how we came up with the scoring equation. And it's more of how much supplies can you give the colonists? The more supplies you have, the longer number of days the colonists can survive. But there's a conflicting requirement in there that the more colonists you have, the higher the score. So you want to kind of balance between how many colonists can you put on the planet and how much supplies you can deliver. And the teams will have to play with what's the balance for number of supplies versus number of colonists they can sustain. And the team with the most days they can survive on the planet is one we're going to deem as the winner. The other aspect of this is, we have within the scoring equation, the final scoring equation, which is something called what we call static payload, which is considering like the performance of the aircraft is the competition objective here. We're trying to help the students design an aircraft that can perform, and one of the things perform is being able to carry payload. So there's another aspect of the scoring equation which takes account into the scoring payload, the static payload, to help make sure that teams can actually earn a score if they have a successful drop or not. I mean, as long as they understand how to get the aircraft to fly and be able to carry heavy payload. So,
talk to me a little bit about like the major differences on the surface. Obviously, we're doing things with an autonomous glider versus just some payload drops last year. What are some new skill sets that are going to have to be implemented to pull off this new rule set this year?
One of the things that's different this year that I think we're subtly emphasizing is in the past, when they dropped the payload, there was no consideration on the impact of the payload on the ground. As long as the sandbag doesn't break, we counted it. This year, we kind of put it out there as when you deliver the colonists, they must not trip the 50G sensor that's on the we'll call it glider for now.
CDA.
The CDA. So they have to really pay attention to soft landing and making sure the landing does not trip the sensors that simulate that if they do trip the sensors, the colonists have died. So that's something different from my perspective that we implement. The different skill set they have to learn this year. Tom?
Yeah, that's exactly right. 2 of the 3 payloads they're not easy to. They're the G sensor on the colonist delivery aircraft, the CDA, and then the water bottles have to be delivered unbroken and unleaking, and that would be a little bit of a challenge. But the teams do get one free ride. The Nerf Howler footballs are pretty bulletproof, and they just have to get them on the target. There's no real survival involved in that one. So it's a interesting trade-off. They've got to carry basically they've got to some teams are going to probably choose to carry some things internally and some things externally. I know for a fact that one team is talking about releasing their glider with the wings folded. They're going to have the wings extend after drop, and I think that's going to be interesting to see if they can make that work. And I think we're going to see a lot of innovative approaches to the whole thing. And I'm dying to see all the designs when they come in for advanced class. The other thing new about advanced class is we went electric on it, and we even limited the power available more than regular class. Power available is 750 watts through a special power limiter that we have, and they use a similar battery pack to regular class. And I think it's going to be, like I said, a very challenging design requirement to get a decent amount of static payload to be able to carry some number of the releasable payloads and the CDA all in the same airplane, if not necessarily all at the same time. So that's going to be very interesting to watch.
This is probably in my 13 or 14 years in CDS for Aero Design, and Lonnie, you've been here longer than I have. This is probably as realistic a challenge as we've ever had in regards to SAE Aero Design, wouldn't you say?
Definitely. Even if you take a look at what's going on in the events around the world today, right? We just landed. Lockheed Martin just landed a spacecraft on Mars. So it kind of plays along with the theme we're going through here. Is some of the challenges that we're having. These are real world, today, live type situations that we're dealing with. We're making the requirements a little easier, but still, these are some of the challenges that we're looking at in the world today.
Yep, and that's why this continues to be a popular event for CDS.
Yeah, that's really important to point out, because I think, at first when you're like, oh, we're going to land stuff on Mars, you're like, well, how many of these kids are actually going to work on that? But again, we're talking to the people that actually have done this, and recently. That was that last one that was in the news, right? So I mean, there are more and more opportunities for this. Is the next step of it.
It's funny. Back to what Lonnie mentioned a couple minutes ago about the impact sensors. When this first was brought up, I think students might be interested to know that discussions were being had about the colonists being actual eggs. But then we kind of decided, well, that might get messy. And, in California, if you might have some fried eggs on the runway. So I don't think anybody wants to deal with that.
Probably attract some animals and bugs. We don't want that. No.
Yeah, we were thinking about taking the egg drop competition that we used to do in high school to the next level.
Oh, yeah.
Yeah. A path not taken this time. Lonnie related a very interesting story just before we cranked up on the podcast. He has been doing some recruiting type work and traveling around to different universities, and he's been to a number of universities that participate in aero design. And there's universal excitement, he said, about the new advanced class. They just think it's killer cool.
I have a couple of seniors who are graduating in December, and they were so distraught at wanting to participate going forward, because this is something that they thought was extremely excited. They're extremely excited about participating in, and I was like, well, that's you can also be a coach or a consultant, continue to stay involved with SAE as the competition goes on. But I've been to maybe 10, 15 universities the last 3 months, and I've looked at a lot of resumes with a lot of kids, and there's definitely a buzz of excitement between the students who's participating in SAE Aero Design, especially the advanced class this year.
There's a big change for this year, of course, and you guys, from my understanding, have a rolling change that one class changes every year, so you have a 3-year run of each general set of rules, right?
Yes.
What do you see generally, I don't know if I want to call them growing pains or differences, like when you get into that first year of a dramatically new class change like we're probably going to see with this one this year?
There's usually some successful teams right away, but as the design as that set of rules matures, teams typically start doing a little better and better overall. So once they build some experience with it, they typically refine and advance, and I would kind of expect that to happen as well.
As far as for me, we've been doing this 3-year rotation for a while now, and the first year of every class, you see a completely different approach on solving the problem, and that's exciting to see, because then you see how the students are thinking, what technology they're trying to implement, and you see different approaches to doing things, and then by the third year, you kind of see that the teams kind of converge on a solution, and everybody's using a similar type of solution, maybe different variants there, but they're converging on a solution, which is kind of interesting how that happens.
And there's a fine line. I know as an outsider, when it's the rules committee, there's a real thin line that we have to walk in order to not only give the teams and the students the ability to be creative and be innovative, but also give them something that they can shoot for that's very definite and very concrete. And hopefully we've balanced that pretty good with this new class. And I'm just as excited as these guys, looking forward to seeing exactly what can come up and what our design and students are coming up with.
We did have a few questions that were passed along to us that were from our friends at the University of Cincinnati Advanced Team. They're known. First of all, regards to the new rules, they're asking, can we have clarification on definition of unmodified payloads?
I've actually added some facts to the website, and the advanced class payloads are one of them. In terms of unmodified, we're hanging in there pretty strictly on the unmodified water bottles, 500 milliliter or 1,000 milliliter. We're not allowing them to. I've already ruled out. Teams have asked lots of things like, can we glue the lids on? And I said, nope, can't do that. That's modifying. They've asked, can we tape up the bottle? And I've said no, because it's going to be too time consuming to remove the tape to do a good inspection to make sure the bottle's not leaking after it hits the ground. Teams have asked if they could put it in a protective cover, and the answer is yes, as long as it's quickly and easily removable. So that's kind of we've had teams ask if they can add a parachute to the water bottle. And since there's no rule saying you can't do that, the answer is they can. But the water bottle itself must be removed from whatever's holding it quickly and presented at processing at the end of the flight to be inspected closely for leakage or damage. And then in terms of the Nerf Aero Vortex Howler football thing, we really don't want any modifications to it. We want it to be the stock toy with preferably the only modification being some magic marker numbers written on the toy so we can identify it when it hits the ground. And so that's kind of part of the game is when we say unmodified, we pretty strictly mean unmodified.
Speaking of the habitats, the Nerf Vortex Aero Howlers, which is a great name that I'm sure we're going to say a lot over this competition now.
Yeah.
They're asking if they have to be uniquely colored to differentiate between them, or must each flight drop have a uniquely colored habitat? Can they color them themselves, if so, or what would you consider modification there?
Gotcha. I don't guess we would yell at them if they painted it, even though it is technically a modification. We kind of expect teams just to put their team number on it and drop it, and we'll identify drops based on team number. It's we're not going to be filling the field with a bunch of them. We're going to recover as flights progress, and I don't think there's going to be a ton of them on the field at one time.
Yeah, I don't think it's a big deal, but the intent of the MultiColors thing was if the teams were to drop, have two passes and have two drops, to be able to identify which payload was dropped during which pass. That was the intent of the different colors.
Mm-hmm. Oh, I got you. That's right. And I was talking, but we had teams asking, well, is it okay for us to buy this color? And I say, you can buy any color you want. So Lonnie reminded me that we are going to allow them to add some color to differentiate their devices for each drop.
Excellent. And of course, many questions like this are going to be popping up here over the season as we approach the first competition.
Yeah, we've already had probably 100 questions on the website, and insanely and high. Of course, mature micro and regular class are relatively mature at the moment. We're getting just a very few questions on that, more so from new participants. But regular advanced class questions are coming thick and fast.
Excellent. And a reminder, where can people ask those questions if they have those for the Rules Committee?
They can be submitted on SAEAerodesign.com. And they can arrange, if a team does not have a login, they can arrange it through Sarah, and they'll be able to log into that website And one of the things you can do is post questions and read the facts, the frequently asked questions.
And you can sign up for an account right on there. A lot of times we do get questions a lot in collegiate competitions. Oh, I clicked the submit a rules question link and it just took me to nowhere. You have to make sure you're affiliated to your team at SAEAerodesign.com. So if you created an account, great, but you need to make sure that you're, choosing your university. Up towards the top of the website, there's a little button that says add affiliation, and you choose your university. Then you'll choose which team you're on, because if you're, a university that competes in all 3 classes or, more than one class, there's more than one team option on there. So you have to be actually tied to a team on there to be able to ask a rules question. So
I can say when I was at North Carolina A&T maybe about a month ago, they demonstrated they were able to drop the football from the airplane on the 50-yard line, and they were about 4 feet off the target. So that was pretty awesome.
Yeah.
So you got some competition, everyone.
So that was that kind of the first realization of these rules kind of in process?
Probably the first physical one that's been seen.
That was at a football game, right, Lonnie? Or prior to a football game, Lonnie?
That was prior to the football game, because when they had the football, they were not allowed to drop because of safety reasons. But prior to the football game, they actually flew in the stadium and were able to drop it.
It's amazing.
That was pretty cool.
Just as historically, we have evolved from, as Lonnie had mentioned earlier, from say 12 or 13 years ago, 2 classes to a 3rd class, and even on the regular side, even for the regular class, Lonnie mentioned earlier, part of the reason we outlaw, I guess is the right word, or do not allow teams to use carbon fiber was faculty advisors and a number of other VIPs, if you will, part of the rules committee back then had indicated that you don't want to just slap together a plane and be able to attempt and complete the challenge. You want to be able to come up with reasons why you're using certain materials, the stress and strain on those materials, and the G-forces that those materials go through in order to complete the challenge. And so without that carbon fiber, teams were now challenged with not only coming up with a design, but backing that design and defending that design as part of their oral presentation. So, Lonnie, I think that was, we had talked, it was at your event back in Marietta that we came up with this clause, and I think it's worked out pretty well all the way around.
Yeah, that was one of the presentations. One of the teams, we asked the question, where's the stress point? We said their answer was, we don't know. We just we just carbon fiber everything and fly. So by taking away the carbon fiber aspect for the regular class, the students and the teams are actually doing real engineering work that are looking at, anybody can build a chair, but can somebody build a chair that can actually lift the weight that was intended to with least amount of material possible? And that's what we were trying to get at with the eliminating the carbon fiber from the regular class was, anybody can build an airplane, but can you build an airplane that's light as possible to carry the most weight?
And without going to the ultimate material. But right. I think that was a wonderful choice, and it makes advanced class truly a design class. It goes back to the very basics in the beginning. And I guess we got into this a little bit at the end. One thing I wanted to mention was, as exciting as the flying is, the other 2 parts of the competition are hard fought as well, and that's the technical paper, the written report. We have literally hundreds of volunteers, many Lockheed Martin and others, that volunteer their time to judge their written reports on their design. It's like a 28-page paper, and they have to submit a plan of the aircraft, and that's a huge amount of work for the team, and some teams really do an amazingly great job at it. And then on the Friday morning of the event, we have 6 rooms usually at our events where oral presentations are given by each team. We kind of also call it a sales presentation. They get up and they have about, what's the time limit, Lonnie? Is it 15 minutes, 12 minutes?
10 minutes.
10 minutes. Teams have 10 minutes to get in there and show us their airplane, talk up its high points, and basically sell it to the judges. And that's a fun. I've judged just a little bit in that, and that was great fun to do, and watch the teams present. And it's amazing how professional some of these young college students can be when they're doing that. And so anyway, that's the other two pieces that get them score is the. And Lonnie, correct me if I'm wrong, but the way the scoring's arranged, the flight score is about half what it can of their final score, and the written report and oral presentation are the other half theoretically. Is that how it's kind of weighted or not?
Yes, that's how we try to weight it, because there's a very variability with the flight. We try to get around 25% presentation, 25% oral report, and 50% flight score.
Yeah.
That's how usually it breaks out to be.
That's going to be great, and it's one of the secrets a lot of teams don't know is if you finishing your airplane at the event and test flying it for the first time is usually not a winning approach. The winning approach is to get it done early and to do that final flight test and refinement before the event starts. So that's a big hint that we're going to throw out there for the teams, and hopefully somebody will listen.
Tom, correct me if I'm wrong, though. Is there not a part of your technical inspection that they have to show you a video?
Only in advanced class.
That's correct.
We try to make advanced class more advanced by insisting on this complex airplane that they get it in the air, drop a payload, and land it successfully, and show us a brief video of that before we even let them go to technical inspection. And we kind of thought that would weed out a few, but man, just about every team is making that requirement. They're getting a test flight in before the event starts and showing us the video. So the teams rose to that challenge rather well.
And it becomes a very stressful time when that doesn't happen before they land at the site, before they
That's
come
correct.
in. Yeah, they need to do prior to when they get off the plane.
Even get to the state they're traveling to, because we always have each year a couple teams that we know they're there because we've heard that they're there, but they haven't signed in at registration or anything yet because they're off in some field trying to get their videos so that they can go through tech. So definitely try to do this.
Yeah, exactly. It's always better to do that. And I'd say, most advanced class teams do, but there's, like you said, there's always a couple that for various reasons they come to the event and they're out. We've had them fly we had them get their video at dusk the day before inspection starts, and even during the day of inspection they come back and get inspected later. So it's a challenge, but I think it's a valid challenge, and it's one teams are doing a pretty good job of meeting, and it forces them to have a proven aircraft. It helps keep the event flowing, because that's the most complex event to judge and watch and monitor. So we want to make sure that the airplane's capable of flight. We've had a couple of occasions in years past where there'd be an advanced class airplane that was not capable of flight. It would get out there and roll down the runway and it wouldn't fly. And we were trying to up the ante and have teams show up with an airplane that flies.
And that's one of the things, Tom brought up a good point. We went to an all-electric advanced class, and we all are electric for regular and micro. And what this does is it eliminates the tuning of the engines we had in the past. And one of the questions, one of the survey results, and so you guys all know, we do read the survey results. The organizers and all our volunteers, everybody that's part of the event gets copies of those. We go through those, and Sarah and I pick out the top categories that we can improve on. And every year, one of them always has been some teams are not able to actually test the design of their plane because they're trying to tune the engine, or the engine gives them trouble. So this is the first year what we're going to do. We don't have that engine, that internal combustion engine that needs tuned, that needs the battery out there on the runway, and they play around with that for 3 or 4 minutes. This year it should be a challenge of, hey, you've got this design, let's see if it works, start the engine and go. So we don't have that, sometimes a delay or frustration from the team standpoint and the volunteers and flight line people, where a team cannot get their engine tuned properly. So Tom, that's a very good point.
Since we're giving out advice, I have two. The first one is for all the teams, all the classes. Pay attention to the environment condition at the field. Those things are announced, and you know where the field's at. Use Google Maps, use the weather, just to understand the weather patterns in that area, so that you can design your aircraft to operate in those environments. That's number one. Number two, and this is to all the project managers for all the teams. You must take into account for the if you're traveling overseas, customs will hold your aircraft for a while. So put that in your schedule. Make sure that you have adequate time to be able to recover your aircraft from U.S. Customs to be able to bring it to the hotel. There's many teams out there that in the past that they ship the airplane on Friday, and it's being held at customs for X amount of hours, and they can't make the competition because of that. And I really hate to see teams travel all that distance to not be able to compete.
Excellent. Sounds great, guys. Looking forward to the event. Thank you, Tom and Lonnie, for joining us here and fit us into your busy schedule out there at Lockheed as well.
Glad to do it. Look forward to meeting you in Fort Worth in March.
Thanks a lot, guys. We'll see you next time.
Thanks for listening to Flight Plans, the SAE Aero Design podcast. As always, we want to hear from you, so email aerodesign@sae.org. The show notes for this episode and all others can be found at aerodesign.fireside.fm. Stay safe, and we'll catch you next episode.